So how in the world do you teach the foundational concepts of statistics and data handling to a 7-year-old without boring them to absolutely tears? I mean, it sounds like an impossible task, right? We usually think of data analysis as something involving complex spreadsheets, pivot tables, and those really dry corporate meetings. But what if I told you that the secret to building incredible data literacy actually starts with a brilliantly simple, super colorful approach that kids don't even realize is math?
Welcome to The Explainer. Today, we're unpacking a truly fascinating piece of source material, Chapter 11 from an early education math textbook. On the surface, it just looks like a standard, playful little chapter for kids. But when we really dig into it, we uncover an absolute masterclass in pedagogical escalation. It gently, almost imperceptibly, guides young minds all the way from basic counting straight into the analytical world of statistics. So, let's explore exactly how this chapter pulls off this genius progression.
All right, let's kick things off with Level 1, Visualizing Simple Data.
Okay, let's dive right into this. The very first step in our young students' learning journey doesn't involve any complex formulas at all. It begins with something entirely intuitive, simple, guided visual observation. What's really interesting here is how the textbook uses these vibrant, highly relatable illustrations. Take these kids standing around in different colored outfits, red, green, blue, and yellow. Now, at this stage, the child isn't being asked to analyze anything. They're just observing a happy, familiar scene. But sneakily, the book is setting them up to categorize visual information just by having them count the number of children wearing each specific color.
Then, the book transitions to another really delightful scene, a fruit party picnic. We've got groups of children eating apples, bananas, guavas, and oranges. And this brilliantly sets up a low cognitive load scenario. For a 7-year-old, categorization right now just feels like a fun game of I Spy. They're simply scanning the page to see who's eating what, completely unaware that they are actually performing the very first, absolutely crucial step of data collection, visual sorting.
Now, once that visual sorting is done, the chapter immediately introduces structure. It brings in this exact table to help kids translate those chaotic, colorful pictures directly into organized data. Suddenly, 3 kids in red shirts becomes a permanent recorded data point in a literal ledger.
And we see the exact same process repeated with the fruit picnic, emphasizing the fruits, apples, bananas, guavas, oranges, and pairing them right up with the number of children. At this stage, the student is simply counting and logging what they see on the page. There is no heavy lifting yet. They're just building their foundational confidence, learning that the real world can actually be captured and organized into neat little boxes.
Which brings us right to Level 2, the power of comparison. So once the kid is totally comfortable logging data, the textbook seamlessly shifts gears to the next level of cognitive difficulty, moving from mere observation to actual analytical thinking. Notice how it suddenly changes its phrasing here. It completely stops asking how many and starts asking which one. The student is prompted to identify the most liked color or the least liked fruit. They are no longer just looking at a single row in their table. They're suddenly evaluating the entire column of numbers to identify the extremes within their newly created datasets. And then, boom, the book hits them with this brilliant exercise. It says, the number of children who like apple is blank, more than, less than, or equal to the number of children who like banana. This is just a fantastic introduction to comparative logic. The child literally has to hold 2 different data points in their mind simultaneously and weigh them against each other. The really crucial thing to understand here is the massive leap that just happened. We went straight from simple counting, how many children are there in the picture, to comparative logic. Yellow color is liked more than blank. And this matters immensely because it forces the child to stop looking at isolated numbers. They are now actively analyzing the relationships across the entire dataset. They're finally discovering the story that the numbers are actually trying to tell them.
Okay, moving on to Level 3, real-world data gathering.
Up until now, everything's been pretty safe and contained within the printed pages of the textbook. But now, it's time to take the student off the page and out into the real world. The textbook provides these fantastic prompts for independent research. It asks students to ask their friends about the number of family members living in their homes. It prompts them to track the favorite vegetables of their classmates. It even asks them to log how students commute to school, whether by bus, auto rickshaw, bike, or bicycle. And the child transforms entirely here. They are no longer a passive observer of some illustrator's drawings. They have literally become an active real-world data researcher.
And to support this huge transition, the chapter gives them these blank, structured surveys to fill out based on their own independent data collection. They're venturing out, asking questions, recording the answers, and then bringing all that raw data back to synthesize it. It's basically the scientific method, just cleverly disguised as a fun social activity.
And finally, we hit the best part, the finale, a mathematical magic trick.
So we reached the end of the chapter, and it's like the authors just knew they had to reward all that hard work. After all the counting, comparing, and surveying, this super charming illustration of two mice holding a present sets the perfect playful mood. It signals to the child that the heavy lifting is totally done, and now it's time to just play with the numbers they've spent the whole chapter mastering.
The book actually presents a magic trick, and I totally want you to play along with me right now in real time. Ready? Okay, step 1, think of a number. Any number at all. Got it? Step 2, double that number. Step 3, add 8 to it. Step 4, minus half of that newly calculated number. And finally, step 5, minus the original number you started with.
Okay, so is the number you're holding in your head right now a 4? Yes, it reveals this magical answer every single time. Now, explaining the algebraic certainty of this to a kid might be way too complex right now, but experiencing the sheer magic of it, that fosters a genuine lifelong love for numbers. Ending on a high note like this ensures the student associates math not with frustration, but with absolute wonder.
Which really leaves us with a fascinating final thought to ponder. We just watched a curriculum expertly guide a 7-year-old from looking at pictures of colorful shirts all the way to understanding real-world data relationships. So if a young child is learning to find the story hidden in the numbers around them, what data story are you missing in your daily life? The world is completely full of information just waiting to be sorted, compared, and understood. You just have to know how to look.